All right, so now that we know how to find the central angles, we know about the vocabulary about words like radius and apothegm and those central angle that, in regular polygons. We're going to now find the area of some regular polygons. So we have to start off with the formula. How do we find the area? What information do we need? Right, and so this formula right here is what we're really going to be looking at. Right, 1/2 times the apothegm times the perimeter. Okay, and so this formula, 1/2 AP, is really just coming from the fact that this shape is made up of a bunch of triangles, right? It's made up of, in this case, 5 triangles that have a height of apothegm, whatever A is, right? And then the perimeter in this is really just saying, let's add up all of those triangles together, right? So you can actually figure out that this formula is really just helping us to shortcut adding up all the triangles, right? 1/2 apothegm times perimeter. So let's start off with a very simple problem. Okay, using our 1/2 AP, okay, we are going to find the area of this regular polygon. So if you're given this statement, regular polygon, regular heptagon, right, I would start off by just writing down the formula, 1/2 AP, okay, and then what you want to do is take an assessment of what information in this formula do you already have, and is there any information that you don't have that you're going to have to figure out? So for this particular example, this is an apothegm, this 5, and I know that because it goes from the center to the middle of a side. So this is A, so I'm going to say my formula is really 1/2 5, okay? And then they tell me right here in the statement about this pentagon that it has a perimeter of 40. This P stands for perimeter, so I actually know what the perimeter is. So I'm just plugging into a formula here. So this is 1/2 of 5 times 40, 1/2 of 200 is equal to 100. And remember that for all area problems, the units are whatever the units of the line lengths are, like centimeters, but it's going to be square units, right? So I would say in this case, the area of this regular pentagon is 100 centimeters squared, okay? So looking at the second example, what you're going to notice as we go through these examples is I'm going to slowly take away information from you. So in some of the very last examples, you're going to have to calculate everything, right? So in this second example, regular heptagon, if you forget, means that it has 7 sides, okay? We're going to, again, start off, I'm seeing the word regular, so I'm going to write 1/2 AP, okay? Oops, A and P, okay? And I see, again, there's an apothegm. 8 is going from the center of the heptagon to the center of a side. So I'm going to say 1/2, that's an apothegm, so we'll call it 8. And in this case, I don't have the perimeter. They didn't give me that statement. What they gave me instead was, how long is one side? Well, one side is worth 10. Regular means that all of the sides are equal. And again, heptagon means there are 7 of them. So really I'm saying 10 plus 10 plus 10 plus 10 plus 10 plus 10, or just say 10 times 7. The perimeter is going to be 70. Okay, so in some cases, you might have to do a little bit of work to figure out one of the pieces of information that you need to plug in. So again, this really just says 1/2 of 8, which is 4. 4 times 70 is 280, okay, feet squared, okay, or square feet. Okay, so you can see like that one required a little bit more work, still not all that crazy, right? So now let's start to get to a place where maybe we have to actually start using what we know about right triangles, right? So this third example, again, I'm going to start off, I'm seeing the word regular polygon. Obviously, it's a regular triangle, aka an equilateral triangle. Right, and I'm going to say 1/2 A times P. Okay, I do know A, here it is. Okay, A goes from the center to the middle of a side. So 1/2. Okay, and it's 4 times, again, I don't know the perimeter. Okay, but now this is a little different because not only do I not know the perimeter, but I also don't know how long any of these 3 sides are. Okay, so what we're going to have to do is focus on this right triangle here and realize that you can use the Pythagorean Theorem to figure out this little section right here. So I'm going to say this is a hypotenuse, so that's c squared, okay, and 4 is an a squared or a b squared, whichever one you want to do, and I'll call this little piece right here x, right, so x squared, okay. So this looks like it says 64 minus 16. 64 minus 16 is 48, okay. And so I'm going to just bring this up here because I'm running out of space. Okay, this says if I square root both sides that x is equal to the square root of 48. And the square root of 48 has a 16 in it, so you can simplify this radical down to be 16 and 3. So 4 square root of 3. Okay, so I'm going to get rid of all this. We know that 1/2 of one of the sides, which I'll go back up to the picture, okay, that this little tiny thing, I'm going to get rid of the x there. Okay, that bottom side, this piece right here, we just use the Pythagorean theorem to say 4 square root of 3. Okay, so here's where we got to be careful. Okay, half of one side is 4 square root of 3, which means if I have another one of those right here, this is also 4 square root of 3. So that's 8 square root of 3 when I add those together, right? So let me use a different color. So one whole side is worth 8 square root of 3, and I have 3 of those to find a perimeter, so that's going to be 24 square root of 3. Okay? So you have to be careful. Whenever you're using these right triangles to help you find some information about a side, you're actually only finding half of one side in your regular polygon. So just be careful with that. Okay. So again, if I multiply this together, half of 4 is 2. 2 times 24 is 48 square root of 3 in simplest radical form. I don't have any units here, so I'll just say units squared or square units. Okay. And so you can do the same thing with a regular octagon like this. So I'm not going to go through this one. It's the exact same thing. The one thing I am going to point out about this, well, here's 2 things that I'll point out about this. The first one is, remember, a radius line can be drawn from the center to any of the edges. So I'm looking at this shape, or I'm sorry, any of the vertices. I'm looking at this picture and I see an apothem. There it is. And I'm seeing a radius, but that radius is not making a right triangle, right? This is a right angle. I'm not getting a right triangle with that radius. So I can redraw that radius line right here instead. This is also 10. From the center to a vertex, it doesn't matter to which vertex, it's the same. Okay, so that's one thing. I've made my right triangle. The other thing is, remember your Pythagorean triples, things like 3, 4, 5s, okay, and 5, 12s, 13s. If you can remember these, it's going to help you out tremendously with regular polygons because you'll have to do far less calculations to get what you need. In this particular case, this is 3 times 2 and 5 times 2. Which means this has to be 4 times 2. So I know right away that half of a side is worth 8. Right? No Pythagorean theorem necessary. Saves me a little bit of time, and it's a really nice shortcut if you can start embracing these Pythagorean triples to help you figure out those missing pieces. If you don't remember them, that's totally fine. You can just rely on the Pythagorean theorem to get your 8 using kind of the old-fashioned way. Okay? All right, so let's take a look at a couple more examples, and then we'll save the last ones for a third video on regular polygons dealing with some more complex problems. All right, so in this case, I'm looking at this hexagon, and I'm saying, okay, formulas 1/2 AP. Oh no, I don't know A, and I don't know P. Right, so this is now starting to get to these examples where I'm not giving you anything. Right, the area is 1/2 AP. I don't even have an A drawn in my picture, so the very first thing that I'm going to do is I'm going to draw on an A. So that goes from the center to the middle of a side, right here, okay, at a right angle. Okay, so this right angle here. And I don't know how long this line is, okay? But what I do know is that every side, which would be this whole thing, is worth 10, okay? Which means half of a side is worth 5, okay? So I just created a right triangle. Now I know 2 of the sides. You can go through, again, I'll let you go through the actual work of doing the Pythagorean theorem to figure this out. Right? You're going to figure out that this is worth 5 square root of 3. Okay? And so here's another little shortcut that'll help you. If you notice that the hypotenuse and one of the legs are this exactly half double situation going on here, this is a 30, 60, 90 special right triangle, and you might notice that this is now the short leg, that's the hypotenuse, which is double. So if the short leg times the square root of 3 would be the long leg, you can actually use that to your advantage as well. That relationship will always work. So I know my apothem is actually 5 root 3. Right? And again, we're going to have to look at this and say hexagon has 6 sides. There are 10 inches per side. That is a perimeter of 60 total. Right? So I can multiply this out and get 150 times the square root of 3 inches if we're leaving it in simplest radical form, inches squared. Okay? So again, here's another example. If you want to try it out on your own, right, we can draw in our apothem. Okay? And say that half of this 6 would mean that this little piece right here, this leg, is worth 3, right? And if you know that this is worth 9, you can figure out this missing piece, which you will have to use the Pythagorean theorem for, because this is not a special right triangle at all, okay? So I'm going to stop the video right there. We have a couple more examples that we can do that are using what I'm calling slightly more advanced techniques involving the central angle, but we'll handle those in a third and final video about regular polygons.